Hey guys, welcome back. This is going to be probability 4. So hopefully everything's going alright. Make sure you're doing everything in a timely manner. Ask questions if you got them. But today we're going to talk about finding the probability of independent and dependent events. This is definitely things that you've talked about. We briefly talked about in chapter 0. I think it should be a walk in the park. Sorry. So independent events are two events that do not affect one another. So an example, what is the probability that I flip a coin and get a heads and spin a spinner and land on red? So let's just think about it. If I flip a coin, does that in any way affect me spinning the spinner this next time? It should not in any way. So we're going to call these independent events. Okay? And so the probability of independent events, we have two events, right? The probability of getting heads, and we have the probability of landing on red, right? So we're going to flip one coin and we're going to spin the spinner. So what we can do if we have two independent events is we can just multiply the two probabilities. So the probability of selecting heads, hopefully we know there's one favorable outcome, that's flipping the heads. There's two total outcomes times probability of landing on red. Well, we have 8 triangles and there's only one red, so we have one favorable outcome and we have 8 triangles or pieces of pizza. And when you multiply fractions, just a refresher, you multiply the tops and you multiply the bottoms. So 1 times 1 equals 1. 2 times 8 equals 16. So the probability of flipping a coin once and getting heads and spinning the spinner once and getting red is 1 out of 16. Okay? So that would be the probability of getting heads and the probability of spinning red. Okay? So let's move on. Example, you roll a die 3 times. What's the probability that you roll a 6 3 times? So you're going to roll a die 3 times. So we got 1 time, 2 times, 3 times. Does you spinning or rolling a die affect what you're going to roll next time? No, it does not. So they're going to be independent events. So we want to roll a 6 3 times. So what's the probability of rolling a 6? Well, there's one favorable outcome out of 6 times. And same with the second time. It'd be one favorable outcome out of 6 total. And same with this last one. One favorable outcome out of 6 total. And you can just multiply these fractions. Now again, let's go yellow. You multiply the tops and the bottoms. So 1 times 1 times 1 gets you 1. 6 times 6 gets you 36. Times 6 again gets you 216. So the probability of rolling 3 6s in a row is 1 out of 216. So that's really unlikely. Okay, so the most important part of today is we have two events that are happening and we have to determine if they're independent or dependent. Okay, so if they're independent, you can just multiply their probabilities together like we have been. You have a bag with 6 green marbles, 4 blue marbles, and 5 red marbles. What is the probability that you draw a blue marble, put it back in a bag, and grab a green marble? So this is probably one of the most famous types of probability problems. You guys have probably seen some variation of this 1,000 million times. But let's just think about the first grab. Because the first grab, what's the probability that you draw a blue marble? Okay, so what is the probability that we draw a blue marble? Well, there's 4 blue marbles, and the total number is 4 green plus, or 6 green plus 4 blue is 10, plus 5, which is going to be 15. So that's the probability of selecting a blue marble on the first grab. Okay. Now we put that marble back in the bag and we grab a green marble. So if we put the first blue marble back in the bag, we still have the same amount of marbles in the bag, right? So there's still 15 marbles in the bag. Now we just need to know how many green marbles there are, which there's 6. So probability of grabbing green would be 6 out of 15. And so we have two independent events, so we can just multiply their probabilities. So we have to multiply across, so we get 4 times 6, which is 24, and we get 15 times 15, which equals 225. Does that simplify? 24. Math fraction. It does simplify. 3 goes into both of these, so you could divide both by 3. So that would equal 8 over 75. With numbers like that, I probably wouldn't be picky about simplifying. But so I would probably take either of these answers. But that's a probability that you grab a blue marble, put it back, and grab a green marble. Okay. Almost similar problem. You have a bag with 6 green marbles, 4 blue, and 5 red. What is the probability you draw a blue marble, do not put it back in the bag, and grab a green marble? So first, we're going to start with our first grab. Blue marble, there's 4 blue marbles, there's 15 total marbles. However, then we don't put it back in the bag. So we have 1 blue marble missing, right? So for our second grab, you have 6 green. You now have 3 blue. And you have 5 red. So our first event affected our second event because we have 1 less marble. So we would say these are dependent events. Okay, and so all you have to do for dependent, we're still going to multiply probabilities. You just have to think about how the numbers would change, how that event affects it. Okay, so you're in the second event, you're assuming the first one happened, so you took out 1 blue. So now, probability of getting a green. Well, there's 6 green after our first pull, right? So there's 6 green. But now what happens is we have 6 plus 3 is 9, plus 5 is 14. So instead of 6 over 15, there's actually 6 out of 14 because we didn't put the marble back in the bag that we drew. So it's dependent, which affects this value right here. But now we can just multiply. So you still multiply 4 times 6, you get 24. Then you get 15 times 14, which gets you 210. Both of these are even, so hopefully we know we can simplify that. And you could get 4 out of 35 if you simplify completely. Again, if they're numbers like this, I probably wouldn't be picky. But numbers like 4 over 8, you know, that's easy to simplify. So that's the probability of the exact same problem as last time, except we don't put the marble back. Okay? So last time is 24 over 225. Now it's 24 over 210. So it changes the probability because our first affected our second. Okay? And so that would be dependent events. They affect each other. What is the probability of 2 aces being drawn consecutively from a deck of cards? So consecutively, they don't tell us they put them back. We're just going to draw 2 cards, and we're going to see if we get 2 aces. So our first draw, well, how many aces are there? there's 4 aces. So there's 4 favorable outcomes. And how many total cards? We've had this stuff in almost every probability question or lesson. It should be 52 total cards. Okay, but we want 2 aces in a row. So if we pick an ace from this first draw, we have 1 less ace, right? Let's say we pick this ace. Well, now there's only 3 aces left. So there's 3 aces left. But also, we took 1 card out of the deck. So how many total is left? Well, now there's going to be 51, right? So these are going to be dependent because our first draw will definitely affect our second draw. So if we put our ace back in the deck, this would be different because we'd still have 52 cards and 4 aces, but we didn't replace it. So they're dependent, they affect each other. So now you just multiply. 4 times 3 gets you 12. Oh boy. 51 times 52 gets you 2,652. They're both even, so we can probably simplify a little bit. Again, I wouldn't take off if you didn't. Math, fraction. This equals 1 of 221. So I guess 12 goes into both of these. So that's the probability you select 2 aces consecutively from a deck, assuming you shuffle. Okay, so that's really tiny. That's a really small probability. So it's really unlikely that ever happens. Okay. What is the probability of 3 hearts being drawn in a row? With each time you draw a card, you put it back in a deck. So if you put it back in a deck, that means you're going to have the same amount of cards every single time, right? And you're still going to have the same amount of hearts every time. So we would call that independent events. Independent. Okay, so let's do our first draw. Well, we're looking for hearts. How many total hearts are there? We got 13 over 52 total cards, right? That's a probability of selecting hearts 1 draw. Well, second draw, if we pick a heart and put it back, we still have 13 hearts, and you still have 52 cards. And same with the third. You would still have 13 hearts, 52 cards, because they're independent. They didn't affect the probability of second. So now you have to multiply across. So 13 times 13 times 13 gets you a very large number, 2,197. And this one's going to be even larger. 52 times 52 times 52. Oh boy. 140,608. Let's see if that simplifies. Divided by 140,608 equals math fraction. And that equals 1 out of 64. Okay? And so that would be the probability of selecting 3 hearts in a row. So that's pretty unlikely. So they're independent because they didn't affect one another. So what is the probability of 2 number cards being drawn if the cards are not replaced in between draws? So the telltale, you know what I mean, sign of whether it's independent or dependent is usually you put it back or replace or not replace, etc. like that. If they're not replaced, then it affects something, right? Just like if we take 1 card out of this deck, now you got 51 total, so that affects it. Where if you put it back, you still got 52 for a second, so they'd be independent. But this one, we're not replacing the card. We're not putting it back in the deck, which means this is going to be dependent. So what's the probability of 2 number cards being drawn? So let's see how many number cards we got. 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 number cards for one suit. So we do 9 times 4. So there's 36 total number cards. So for the first draw, there's 36 total number cards. And we said there's 52 total cards. Now for a second draw, you pull out one of the number cards. So one of them's out and we're not putting it back. So if you take out one number card, you then have 35 number cards. And if you took one card out of the entire deck, then there's 51 total cards. So we have our 2 events. Now we just multiply. So 36 times 35 gets you 1,260 over 52 times 51 equals 2,652. Not sure why I made such a big gap there. So 1,260 divided by 2652, math fraction. That's about 105 over 221. So again, I would accept either of these. So that's probability. You select 2 number cards. Those aren't terrible odds. But hopefully we're seeing the difference between independent and dependent, okay? So independent, they don't affect each other at all. Like the first example, flipping coin, spinning a red. And then these, if you're taking a card out and you're not putting it back, it obviously affects the second event, okay? So let's make sure we complete this assignment. It's on that HyperDoc by tomorrow at 4 p.m. Hope you guys have a great day, and I'll see you guys tomorrow.